we're going to look at what the graphs look like between the derivatives and maybe figure out what the heck that tells us. So in 30-1, when you were asked to find maxes and mins, the only way we could ask you to find them is with your calculator. In grade 11, you only looked at quadratics. So we could make you complete the square and give us the vertex, because it would put it in vertex form and you give us the max and min from there. But then in grade 12, we could ask maxes and mins of everything. So then there was no like just complete the square form to get that, because you have to actually use derivatives to get that. So the first graph we're going to look at is y equals 3x cubed plus 4x squared plus 5x minus 6. Type that in. That. Right? Okay, so I don't even know how that happened. Got sidetracked, but you're welcome. Horizontal tangents, where do they occur? Oh, horizontal. Saskatchewan. Yes, there's that. See, it all comes full circle. All right. Just like the tire using me for traction is a 5-year-old pushing the bus. Okay. So where would a horizontal tangent appear? The max and mins. So here is where it's going to be the max and mins. Everyone paying attention? So this is going to be max mins, but it also could be points of inflection. So if I go to draw the second derivative, let's think about it. Y equals, what is our second derivative, or our first derivative, not second. What's our first derivative? 9x squared plus 8x minus 5. It's a quadratic, correct? So polynomial graphs are the easiest because if you have a cubic, your first derivative is going to be a quadratic, the next one's going to be linear, right? Because you lose a degree each time because you're using power rule. So we want to know where the tangent, m tangent is 0. So that max and min value is going to be what on the first derivative? Where m tangent equals what? Where our first derivative equals what? 0. Right? Where there's a horizontal slope. So on the second derivative where this equals 0 is going to be where the maxes and mins are, because this is the horizontal tangent, correct? So I'm going to go here where the maxes and mins exist, and I'm just going to follow that straight down. And that's going to be x-intercept of my derivative. Follow this one down. It's going to be my x-axis. That's not the minimum. What am I drawing? This is the minimum. Did you see how the mins and maxes become the x-intercepts of the first derivative? Because it's where m tangent is equal to 0. It's where y equals 0 on the first derivative. Y equals 0 is x-axis. Okay? We're not going to talk about the rest of that graph for right now. We're going to just go to the next one. So, well, we can talk about this graph. Let's sketch that graph. So type it into your calculator. 9x squared plus 8x minus 5. Okay, guys, find the x-intercepts of this graph. Go second, trace, 2. Left bound, right bound, enter. What's my x-intercept at? Same as the minimum, or the maximum. Do you see? It's the exact same number. Yes? So this here is negative 1.31 and 0 now. What do you think this one is? Second, trace, 2. Left bound, right bound. Weird, 0.42. I know, crazy. Do you agree? Okay, let's get the minimum of this graph. Second, trace, minimum. left bound, enter, right bound, enter, and you get 0.44 and negative 6.77. You guys should be drawing this. So it's negative negative 0.44. Nico watching. Nico, you're gonna be lost.
I'm watching.
No, you're not. Okay, stop with the marker. -1, -4 is on this graph, and 0 and -5 is on the graph. So we have a graph like this. And our minimum, which is what matters, is at negative 0.44 and negative 6.78 rounded. So now I treat this like this is the original. Okay? And then this is my new derivative. So y double prime is going to be 18x plus 8, which is a line. Correct? We're going to end up with a linear graph. What is going to be my x-intercept on my linear graph? Where is it going to be located at? Negative 0.44. So I'm going to come down here, and that'll be my new x-intercept. Right? So the mins and max of the previous graph become the x-intercepts of the next one. The mins and max of that graph become the x-intercepts of the next one. Because that's where the tangent slopes exist. Do you get what I'm saying? That's a big thing we need to take home today. That the max and mins become the x-intercept of the first derivative, because that's where horizontal tangent slopes are. Max and mins of that graph become the x-intercept of the next graph. Okay? We'll talk about increasing and decreasing tomorrow.